When I spoke about variables, I explained that you can create a variable at the beginning of your program, but then as we go later on and your program gets very big, you can lose track and not know anymore exactly what type of value is inside the variable. That's the very powerful thing about variables and programming in general, is that you can program stuff which doesn't have to always exactly be the exact same thing always, but it could actually change every time you run the program again. Which means like this: you can have your program make a variable and right away give it a number, let's say like 10, assign that number to the variable, and then you can just program ahead your whole entire program, whatever it may be, knowing for a fact that the variable x has the number 10 inside of it. And based on the fact that x has 10, you will make a whole program around it. Who knows what your program is? So that's a very static type of program, because anytime you play it around, since your compiler already made the .exe file with the exact code you typed in that you want variable x to always be 10, and you made your whole program based on that, then that's it. That .exe file will always play it in this way, that the variable x is 10, and based on that the whole program will run the same exact way every time. However, in programming we are not so limited. We can have a lot more dynamic action. For example, when we saw in a different video that you can make a variable and then ask the user to type something in, and then you can use a different type of magic which will take input from the keyboard and put that input into a variable. We see now that our program will be handling very dynamic information. The user is not forced to only type in the number 10, and you cannot base your whole program knowing that x will always be 10. That is not true. You probably don't know at all what type of what number exactly the variable x will hold. As we see, we're just waiting for the user here to type something in. You see, but that's the power of variables and programming, that you can prepare yourself and your program for whatever value this variable may have, so that even though we already compiled it and we already like sold our program that .exe file, and at this point there's nothing you could do to change the code that's inside that program, because it's already on the market. But that doesn't matter, because you trained your program to take care of a lot of situations. This program could take care of the variable x, whether it contains 1 in it, or 2, or 3, or any other number that it may hold. You prepare your program to take care of any situation it may encounter, which is important to your program. So this just goes to explain that you don't always have to decide everything exactly which actions to take when you're compiling your program, when you're typing up your code for the compiler to make. You do a lot more than that. You prepare for any situation and you instruct the compiler exactly what the program will do, and the running program, while it's actually running the .exe file, will be taking the decisions all by himself during runtime, which is something that is a step further than your control. So if you thought that to make a good program you have to type in every single situation and every single thing you have to do, like you have to prepare for if x is equal to 1, or if x is equal to 2 and 3 and 4 and all that, you don't. You are just going to give the program very general and generic instructions, and the actual program on the spot, while the program is running, will take the final decision of what action to take based on the variables and the information of whatever value they may be actually holding while the program is running. Now, while this concept may seem very powerful, that you're just typing a little bit of stuff and that will take care of many types of situations, that's also where the problem begins, because since your program may end up running and having consequences of very different situations, there may be one situation or a few situations which you didn't take into consideration and you didn't think about it, and then suddenly while the program is running that situation happens. For example, in this code right over here, we prepare a number variable, and we propose the user to type something in, and then we will take whatever that user typed in and put it into this number variable. So right now we're preparing for many situations. We're preparing for if the user types in negative 345, because this is a integer variable which, at least on my compiler, could go below 0. It is considered signed, and it can hold numbers below 0. And we are also preparing for the situation of if the user types in 0 or 1 or 2 or 3 or 4 or 5. So we're preparing for many situations, and we are handling all of them within just a few lines of code. You see, we weren't forced to type in a whole bunch of code and prepare for just in case the user may type in 1, and then do it all over again for 2, and then all over again for 3, because that's the power of programming and variables, that you can prepare some generic code which is ready to handle many types of situations, which you, the programmer, while you're typing up your code, you don't even have to know what that specific situation is. You're just preparing for all and any of them. But there's something we forgot. What if the user will decide to type in a few letters just for fun? We didn't prepare for that situation. We were thinking all about our integer variable and how the user will type in a number, and we were so glad how the user will type in any number he or her wishes, no limitations whatsoever. It could be anything, 0, 1, 2, 3, anything he wants. And we didn't realize that what if the user wants to type in a few letters? Now, we compile our program. The compiler goes through all this code, and it sees that everything is spelled correctly, everything makes sense, so everything compiles correctly with no compiler errors. And then the linker comes into play, and it links together all the stuff that needs to be linked, and no problems over there either. So we have our .exe file, the actual final program. So far everything looks like it's going good, and the problem only shows itself when you've already sold your program on the market, and some user out there typed in some letters, something you never dreamed about, and suddenly your program doesn't know what to do with a couple of letters instead of a number. The program can't put a couple of letters inside the variable because the variable is a number. And so right there we have a nasty runtime error. Not a compiler error, not a linker error, but a runtime error. Now when your company gets the phone call that this user, when he was running a program, it crashed, and you won't know specifically that he types in some letters, you're going to try to look over the code over here and see what's the problem. I can't figure it out. I make a variable, I ask the user to type something in, and then the user types it in and it goes into the variable, and you can't seem to see what's the problem. It looks like a nice piece of code that's prepared to take care of a whole bunch of situations, whether the number is 0 or 1 or 2 or 3, etc., etc. Looks like we got everything covered. Again, no typing errors, no compiler or linker errors. So what in the world could be the problem? As a matter of fact, it looks like there's no problem whatsoever. That's what's so difficult about runtime errors, that it's not something as obvious as a typo, typing mistake, or a linker error in the project properties. It's a lot more complicated than that. It is something which you may need to sit down and think out through all of the thousands and thousands of possibilities which could ever happen when the user is running this program through this piece of code. And sometimes you don't even know which piece of code the error may be coming from, until who knows how long it'll take you to figure out that, oh, over here the user has the possibility of typing in a few errors instead, typing in a few letters instead of a number, which is why runtime errors is pretty hard to find and fix, because it has what to do with going into the thousands and thousands of possible situations that could ever happen with your program, to track down which of those situations have we not thought about and protected from while putting together our code. The solutions to runtime error include testing your program thousands of times, trying to use it and going through many different types of situations to try to tease them all out and test if any of them cause any trouble. Like if you ever heard of beta testing of some big program out there. Another one is error reporting, when you call up the company and tell them that I was in the middle of doing this and this and that when the program crashed, and so the company could try and figure out what to tell the programmers, where could the problem have been. And then of course there is something called debugging, which we will visit later on in another video.